The 3 Series MDO is designed for intuitive operation and fast, insightful analysis. It is available in 2 and 4 channel versions with upgradable bandwidths from 100 MHz to 1 GHz. The 3 Series emphasizes signal viewing area with its 11.6-inch high-definition display. Every knob, button, and gesture has been thoughtfully designed. Quickly turn on other waveforms, channels, math waveforms, or reference waveforms. Each waveform gets its own badge in the settings bar, and if you decide you don't want a waveform any longer, just swipe to delete it. Select any waveform by touching its badge or by pressing the front panel button. Traditional knobs provide control for important settings, while LEDs indicate which source the knobs are assigned to. Whatever object you want to adjust, you simply double tap its object on the display. For example, here is all of my channel 1 settings, or for example, I could change my trigger settings. Simply double tap on them to get the menu. When you're done, touch anywhere outside to dismiss the menu. Now let's take some measurements on channel 1. To do this, I will select Measure, select Peak to Peak, and Rise Time. I'll dismiss the menu, and notice that each measurement I selected now has a badge in the results bar indicating the measurement results. Tapping the magnifying glass activates the zoom function. You can use simple pinch and expand gestures to adjust your zoom view. You can pan through your record, or you can simply grab the zoom overview box and drag it across the display to adjust your zoomed view. In addition to touch, you can drive the scope's user interface through mouse as well. For example, I can drag my zoom box around to adjust my zoomed view, or I can come over here and turn off zoom. The scope can also be controlled over Ethernet or USB interfaces. It has an HDMI interface for an external monitor, and other rear panel connectors include the aux out and optional AFG output. The 3 Series MDO is available in 2 and 4 channel versions and can be configured with 5 different bandwidths from 100 MHz to 1 GHz. You can buy the bandwidth you need today and upgrade it later. It has 10 million points of record length. The 1 GHz models support 5 gigasamples per second on all channels. 100 to 500 MHz models sample at 2.5 gigasamples per second on all channels. Many trigger combinations are available, from very basic triggers like edge triggering to much more advanced triggers. In this case, we are looking at an I2C bus with clock and data, and I want to trigger on the beginning of a packet. To do this, I'm going to select my trigger menu, select pulse width triggering, and then say I want a pulse width greater than 2 milliseconds. And now we have isolated the start of packet on our I2C bus. A new preamp ASIC delivers 1/3 less noise than our previous generation scopes, while high-res mode boosts the vertical resolution from 8 bits to up to 11 bits so you can see even more detail. Now let's use cursors to measure this negative pulse width on channel 2. To do that, I'll select cursors, and you can see they're currently assigned to channel 1. I'm going to touch the channel 2 badge to select channel 2. I can change the cursor location by simply moving it and dragging it around through touch, or I can use the front panel knobs to adjust the cursor locations. So let's measure this pulse width. And it looks like the pulse is 43.8 microseconds wide. To turn off cursors, simply touch the cursor button again. Now let's look at some automated measurements. To do this, I'm going to select the Measure menu. On channel 2, I'll add a peak-to-peak measurement. On channel 1, I will add a period measurement and a rise time measurement. Notice that as I add the measurements, each one gets a badge in the results bar. To see how the measurement varies over time, I can double tap on a measurement, select Show Statistics in Badge, and now I can see my mean, standard deviation, maximum, and minimum for that measurement. wide range of other probes are compatible with the TekVPI probe interface, including single-ended active probes, differential probes, power rail probes, current probes, and even optically isolated differential probes. You can further expand your system visibility with digital channels. With the MSO option, you get a 16-channel logic probe. When you plug in this logic probe, you can activate digital channels by simply touching the D15 to D0 button. Here we're looking at 8 digital channels, and the badge down here indicates activity on each of my digital channels. With MagnaView, you can sample at up to 8.25 gigasamples per second on every digital channel. Unlike traditional SWEP spectrum analyzers, the capture bandwidth of the 3 Series MDO is exceptionally wide at up to 3 gigahertz. Usual spectrum analyzer-like controls are found in the horizontal menu, where I can set my center frequency, span, and RBW. In this case, I'm going to set my center frequency to 2.4 gigahertz, and I'll set my span to 10 megahertz. You can quickly and accurately decode serial buses with the 3 Series MDO. To get a bus view, I will select bus 1, and I'm going to tell it I want to look at I²C and set my thresholds. And you can see that I'm now getting decoded serial bus information here. I'll move this bus down here so it's easier to view. And we can see addresses and data packets and such going by. Beyond simply decoding the bus, we have the ability to trigger on packet-specific content going by on the bus. To do that, I would go to the trigger menu, select bus as my trigger source, and let's say I want to trigger on reads or writes to address 50. So I'll enter 50 and close my menu, and you can see that we are now triggering on reads and writes to address 50. If we wanted to look at more, we can scale out and see a longer period of time. And another way of viewing this packet information is with what we call a results table. With a results table, if I select bus 1, you can see all of the packets that are being acquired in each acquisition laid out in a tabular format for easy viewing. The optional AFG can generate a wide variety of signal types and has performance comparable to a standalone function generator at a fraction of the cost, and it's built right into the scope. Signals are delivered through the 50 ohm output on the rear of the scope, and in this case, we're routing it to channel 2. To use the AFG, simply double tap on its badge. As you can see up here under waveform type, there's the wide variety of waveform types we support. On channel 1, I have captured a intermittent runt pulse. So what I'm going to do is select arbitrary waveform type and load waveform from channel 1. Let's go ahead and do that. And if you'll recall, I said that we were bringing the AFG output into channel 2. So I will turn on channel 2, and we will do a single acquisition here. And you can see that we have faithfully recreated the input from channel 1, playing out the AFG and captured on channel 2. With the optional power analysis package, it's easy to make end-to-end power supply measurements. Making power measurements is just as easy as regular measurements. To do so, go to the Measure menu, select the Power Measurements panel, and in this case, we want to look at power quality. Once we've selected it, you'll see we get a new badge in the results bar indicating things like true power, reactive power, apparent power, and many other useful pieces of information. In addition, we can even do harmonics analysis on the AC input. Moving on to the switching section of your power supply, you can also take switching loss measurements. And automated ripple measurements make it easy to check the outputs of your supply. When you register your 3 Series MDO, you get a license for free access to a trigger frequency counter and an integrated DVM. All of the functions I've talked about in this section can be configured in a new instrument, or they can be added later. You can even upgrade bandwidth. So you can buy what you need today and add performance and capabilities as you need them in the future. The 3 Series Mixed Domain Oscilloscope offers an integrated spectrum analyzer, so you always have the ability to make spectrum measurements right at your fingertips. Familiar spectrum analyzer controls are immediately accessible. For example, center frequency, which I will set to 2.4 gigahertz, and span, which I will set to 10 megahertz. The in-connector and dedicated acquisition system deliver RF performance comparable to standalone entry-level spectrum analyzers, and well beyond that of a typical oscilloscope FFT. Unlike traditional SWEP spectrum analyzers that have very narrow band captures, the unique design of the 3 Series MDO enables exceptionally wide capture bandwidths of all the way up to 3 gigahertz, which is what we're actually looking at right now, and what enables us to see this signal here at 900 megahertz and 2.4 gigahertz at the same time with the same capture. These automated peak markers make it very handy to see quickly what's going on in the spectrum by telling me the frequency and amplitude of the highest amplitude peaks in the display. And in fact, we can occasionally see a harmonic appearing at 1.8 gigahertz in our display. Better than all of this is the fact that the display remains lively even with very narrow resolution bandwidths. In this case, I'm going to set my resolution bandwidth to 100 kilohertz. And we are now looking at 3 gigahertz of spectrum with 100 kilohertz resolution bandwidth and still getting an update at least once every second. And with automated RF measurements, you can quickly characterize your device using standard measurements such as channel power, adjacent channel power ratio, or occupied bandwidth. In this case, let's turn on channel power, and you can see our results badge indicates channel power of minus 14.6 dBm. For dynamically changing RF signals, you can use a feature called spectrogram that enables you to see how the spectrum changes over time. Notice that as the spectrogram builds, it's very easy to see signal activity going back and forth between different frequencies over time. The integrated spectrum analyzer, along with a near-field probe, makes it very easy to track down noise sources in your design. For example, here we have found a 100 megahertz radiating clock along with all of its harmonics.
Find out more at Vicom's website.